Welcome back to R for Economics. In this one, we're going to be looking at an elastic net regression, which is a regularization and shrinkage, just like a lasso and a ridge regression. An elastic net is actually a combination, combines both a lasso and an elastic net in a single regression in order to reduce the number of parameters required for the model. So we're going to install the package, glmnet, bring in the glmnet library. And if you watch the lasso video, you'll be able to see the setup, which is looking at 100 observations for training, 25 for testing, 75 potential regressors. And if we set up our data with normal distributed errors and regressors, and then we set it up so that only the first 5 coefficients are non-zero. All the rest are 0. So we have 70 regressors, which are of no value to us. So we're going to generate our series and for both testing and training. And if we run OLS, we can see that we get a fair number of strong parameter values in the first 5, but then we've got some other ones that come in. And we can see that the OLS mean squared predicted error is 2.44. So if we run an elastic net, we have to actually choose what alpha is. At 1, it's a lasso. At 0, it's a ridge regression. And anywhere in between 0 and 1, it becomes an elastic net. So we're going to set it to 0.5. And we can see that some of the regressors seem to have this strong influence on the model. And you can see the degrees of freedom that it's only selecting a few as it moves up in as the lambda decreases. So if we do a cross-validation version where alpha is equal to 0.5, we can see that it declines and drops to about 9 or 10 as the preferred. So we have 1 there, and then these ones. So it's actually closer to 6 or 7 regressors. So we can see that it captured all the 5 important ones, plus it has this other one at 48, which seems to be significant enough for it to maintain. Now, we probably want to find out what the lambda is that is associated with this minimum. And we can run that one in predictions, and then also the optimized lambda in order to compare our elastic net and our optimized one. And you can see that these are both improvements over the OLS as far as its squared predicted error. And also, we should see that the sum of the coefficients is a decrease, and the number of regressors that it's retaining. You can see that the non-cross-validated one is down 7, and then only a few more are moved for the optimized one, optimized lambda. Okay. Now these are all at alpha is equal to 0.5. They can be tested at other values and to see if these improve or if your number of regressors actually moves around. So you can try over values alpha between 0 and 1. Great, and we'll see you in the next video.